Alright, here's question 2. Sent in by a student. It's not like wow, it's like whoa. Here's the question. Determine the molecular formula of a compound with a percent composition of 54.9% carbon, 9.1% hydrogen, 36.4% oxygen. Its molar mass was found to be 87.9 grams. This is a two-step problem. First, you have to find the empirical formula, the lowest ratio of elements per compound. Then you find the molecular formula, the true number of elements in the compound. So to start, we assume that we have 100 gram sample based on the percent composition. So we change 54.9% into 54.9 grams of carbon. Same thing for hydrogen, 9.1 grams of hydrogen and 36.4 grams of oxygen. Next, we convert to moles, just by dividing each element by its molar mass. And the answers are 4.57 moles of carbon, 9.01 moles of hydrogen, and 2.28 moles of oxygen. Then, we divide by the smallest number we just calculated. That'll give us the lowest number of moles in the compound, setting the ratio. So we divide by 2.28. We get 2 carbons, 3.95 hydrogens, which will round to 4, and 1 oxygen. So that's the empirical formula. C2H4. Oh, it's not like wow, it's like whoa. That rhymes. So for part 2, we need to find the molecular formula using the information we just got from the empirical formula calculations. So first, we need to find the mass of 1 mole of the empirical formula. And we do that by taking the number of atoms of each element and multiplying that number for each element by the atomic mass from the periodic table. So 2 times 12.01 for carbon, 4 times 1.01 for hydrogen, and 1 times 16 for oxygen. When we add it up, we get 44.06 grams per mole for the empirical formula. Next, we're going to divide the given molar mass from the problem, 87.9, by the empirical mass that we just calculated, 44.06. And that comes out to be 1.995, but we'll round that to 2. Finally, we distribute that number, 2, through the whole empirical formula. So 2 times C2, 2 times H4, and 2 times O. That gives us the molecular formula of C4H8O2. Wow. I mean, whoa.